This is Dr. Carroll, and this video is about inheritance, overloading methods. Hopefully you've already seen my inheritance introduction video. So let's start with a simple example of a shape class which has an area, and we've made sure to make it protected so area could be inherited. We have a constructor, we have a parameterized constructor, set and get area, and a print method in shape. And we have a circle class that inherits from shape, and we know it inherits because we have the keyword extends here for shape. And so because we're extending shape, we don't have to repeat the area field, and we can just supply what is unique to circle with radius here. And so then we'll have our own set radius. We could have had get radius as well, but we're set radius. And notice in set radius we have area. It's not defined in circle, but it is defined up here in shape. And so because we are inheriting that field, because it is protected or public, but in this case it's protected, we can use it and set it, and it works. Also, let me show you a simple little driver code here that we are creating a new circle and calling set radius on it, which is fine because set radius is a method of circle, but we're also calling print on circle, and you can clearly see there's not a print method in circle, but there is in shape. Okay, so let's compile that. Yeah, it compiles, and when we run it, we see that it executes and does indeed call the shapes print method, and it displays the area for a circle that has a radius of 5. Okay. Now, what if we wanted to add print to our circle class? Would it overload the print in the shape class? So let's review just real quickly overloading methods. And so in another video I talked about this. And so within a class, method signatures must be different to overload a method. And by method signatures we mean 1, the method name, and 2, the parameters. And then specifically what we mean is the order and type of the parameters. So with overloaded methods, they have the same name but different parameters, either type and or order. And again, remember the name doesn't matter for signatures. We don't take that into consideration. So different name same name but different parameter types for overloading. So no, adding print to the circle class will not overload another method. And so that brings us to today's topic, is overwriting methods. So an overridden methods have the same signature, but they are in different classes. So same name, same order and type of parameters, but they're in different classes. And so an example would be putting print in, having it both in shape and circle. We would say that the circle one overrides the shape one. So let's put that in circle. And you know what, let's save some time and let's start with this one here. Okay, but we also want to display its radius, because that is what is unique to the circle class. And there we go. So let's make sure it compiles. Woohoo! It compiles. And notice it does indeed run now with the circles print method. And we know it's the circles because the radius is 5, and shapes don't have, not all shape objects have a radius. Okay, great. There we go. We have now overridden a method, same name, same order and type of parameters, or succinctly said, same signature. And that's how we override a method, which is different than overloading. When we want to override a method, we should add in the override annotation. And notice it's a capital O preceded by an @ sign. So @ override with a capital O. So annotations are optional. They're not required, they're optional. We just saw it, it ran, it compiled and executed without it. They're optional. What they do is they provide information to the compiler to say, hey, this is my intention, this is what I'm trying to accomplish. So an analogy would be like using your turn signal in the car. It's not required, but it's helpful to others around you to drive safely, to know of your intentions. So just like your turn signal, if you don't turn, you're likely for an alert to go off from another driver. Well, override tells the compiler that the next method after override should override another method. And so if the signature does not match that of another method, then the compiler will report an error to you. So let's go in and add override now to our circle class. And we just put it right here, right before the method, and we tell it to override. And as we can see, it will compile again and run just the same, but what we've done is we provide the override. So now if we said print value, notice we have changed the signature of this method, and so now if we tried to compile it, notice it says, it freaks out and it says method does not override a method of the super type, but you told me it should have in the annotation, but it doesn't. So that helps you out to say, hey, this is supposed to overrides shape.print. That's what we're accomplishing here. And so we're making the intention clear to the compiler so it can help us out in case something changes at the shape level or something else. Okay. And so there we have the override annotation. Now remember that inheritance is all about code reuse. We can reuse code from the shape class, but notice we've copied some of this code from the shape class. And so is there a way we can reuse the code from shape class and then add some output to make it call radius? So let's see, what if we just called print here to get it to, we're trying to get it to call shape. We want it to call this print class, this print method. So what happens if we call print here? Does it compile? Oh, it compiles. Okay. What happens when we run it? Oh boy, that did not look good. I'm scrolling up, I'm scrolling up, I'm scrolling up, I'm scrolling up, I'm scrolling up. What did it say? Exception in thread main, stack overflow error. What is going on there? What happened? What happened is in the circle class, we said call print, and in print, when it called print, it said call print. Well, which print is it? It's the one that's closest to this method. So it's this own print method. This is called a recursive method. We'll talk later about this in another video. And so it sits there and calls print, and then it calls print, and then inside print it calls print, and it calls print, and just calls print over and over again. This can be illustrated maybe better by having it display something and then call it. And again, we scroll way up. Notice what it did. It called radius a whole bunch of times because calling print, it would display radius and then call print again, which means display radius, call print again. It just sits there and does it until it exceeded the amount of space it has on the call stack, and then we get stack overflow. The stack we overflowed on the stack. So that's not going to work. We can't call it that way. So let's comment this out because that's not going to work. Results in stack overflow. And now you probably see a little bit more where the stackoverflow.com gets its name. Something wrong happened. I need some help. So what else could we do? Let's go back to the notes here and let's learn just a little bit more about what we can do. So when we're trying to call the base class's method, so in this case shape, what we'd like to do is do something like call shape.print. And how would we do that? We do that with a special keyword. And so let's introduce a new keyword here, super. And I've colored it to indicate super is a keyword. And what super refers to is the implicit base class. And so an example would be super.print. And so we can add that into our circle one here. And so instead of print, if we did super.print, then it says, hey, the class that I want to call this in, it's the parent of this class. And the parent of this class is shape. So that's going to call shape.print. It's going to call the print method in shape to be able to do that. And so let's see if this works now. Yay, it compiles, so that is a keyword. And we run it, and sure enough, we get shape area from the super.print, and then we move on to radius and display radius there. So now we are reusing this code and then extending it, or better said, we're overriding it with our own method. So does super remind you of another keyword? So remember the keyword this? That refers to the current class that we're in. For example, if we wanted to use a parameter name that was the same as a field or a data instance variable, we use this. And so, but super, on the other hand, refers to the super class, the parent class of it. So thanks for watching this video. Check out the next video on the object class.